All right, everybody. Let's do the next section. So 11.3. All right, so now that we know how to do probability, we're going to look at a special kind of probability. Well, there's a lot of special kinds, but this is just one of them. Probability of multiple events, so multiple things happening together, I guess. Okay, so the probability of A happening, okay, so there are two different words you want to learn. Independent event, Okay, you're going to have to try to find it. Okay, so there are two different kinds. One is called independent event, and the other one is called dependent event. So I'm going to tell you what I mean. Independent event means the probability of A happening does not affect the probability of B happening. So whatever happens to A, what are you doing? Okay. Whatever happens to A doesn't affect B. So, for example, if you toss a coin and getting ahead and picking a queen from a deck of cards have no relationship to each other. Because you getting ahead doesn't mean that you're actually going to have more chance of getting a queen. Right? They have nothing to do with each other. So those are independent events. Or you roll a 6 on the dice, and then rolling 3 the next time. They are not going to affect each other. So getting a 6 does not make you get a 3 more likely the next time. Does that make sense? Okay, so these are going to be independent events. Dependent event means that the probability of A happening does affect the probability of B happening. So one thing happening makes the other one change its probability. For example, if you pick a queen in a deck of cards and then pick another queen from the same deck without replacement, that's going to affect your probability, right? Picking a queen, putting it aside, now you only have 51 cards. You're going to try to take another queen out. That second time, the probability changes. Yes? And then, for example, in a jar that has 6 red and 6 blue marbles, the probability of picking 2 red marbles in a row. So take a red out and then take another red out. The probability of the first one will affect the second one. Yes? Thank you. All right. Okay, so if two events are independent, then the probability of both of them happening is probability of A and B. Probability of A and B is defined as probability of A times probability of B. If two of them are independent, meaning one cannot affect the other, then if you want both of them to happen, you're going to multiply the probability of each one. For example, at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? Okay, so what is the probability that you get a diet drink and fat-free chips? All right, so first you always have to ask yourself, does picking a drink affect your probability of picking the chips? No, why not? The two separate things, and then you're blindly picking, right? You're not saying like diet drink, ooh, I better get a fat-free chip or else I'm gaining calories. So you're not actually looking and picking, you're just going like, okay, what am I going to pick? So they don't affect each other, so we're going to multiply the probabilities together. So the probability of diet drink times probability of fat-free chips? Okay, what's the probability of getting a diet drink? So go back to 2 days ago. Diet drink out of total diet drinks. You said 10%? Yeah. So you want one diet drink out of, wait, hold on. That is, no. How many diet drinks are there? 10. How many total drinks are there? 15. Okay, so the chance of you picking a diet drink is how many diet drinks are there out of total, right? Okay, so what's the probability of picking a fat-free chip? 8 out of 20. Okay, so, Okay, so now we're just going to calculate this or simplify it. So the answer is 4 out of 15, or about 27%. Okay, in these kind of word problems, what you want to do is look for keywords. For example, this one. What's the probability of you get a diet drink and fat-free chips? So you want to circle and. These are the and probabilities. You want to circle and. Later on, we're going to do or, so you want to circle those keywords, okay? All right, next. What is the probability that you get a regular drink and regular chips? All right, you guys can do this one. Okay, what you guys get for B? Regular and regular. 4? 20%. All right, next. Let's talk about this new word, mutually exclusive. Mutually exclusive means two things cannot happen at the same time. It's not possible. Mutually exclusive means they cannot happen at the same time. Oops. Two things cannot happen at the same time. For example, tossing a coin once, getting a head and a tail together. That's not possible. So you toss a coin, it's either head or tail. You cannot get head and tail at the same time. So that's mutually exclusive. Yes? Okay, or picking a card that is a king and ace at the same time. That's mutually exclusive. Okay? All right, so for example, you roll a standard number cube. Standard number cube goes from 1 to 6. Are the events mutually exclusive? All right, so let me just do the first one with you, and then you can do the rest with your partner. Rolling a 2 and a 3 at the same time. How many people think they are mutually exclusive? They cannot happen at the same time. How many people think they are not mutually exclusive? You can get a 2 and a 3 at the same time. Okay, so let's vote again. How many people think they're mutually exclusive? They cannot happen at the same time. Okay, good. So they are mutually exclusive. So are they mutually exclusive? Yes. All right, so you and your partner are going to do B, C, D. Are they mutually exclusive or not? All right, let's try it. B, how many people think, yes, they are mutually exclusive? You cannot get not an event number, I'm sorry, even number. Even number and a multiple of 3 at the same time. How many people, you cannot get an even number and a multiple of 3 at the same time. Yes, they are mutually exclusive. Okay, how many people think, no, they are not mutually exclusive? You can get an even number and a multiple of 3. That's correct. What number is even and a multiple of 3? 6. So if you get a 6, that will fit both descriptions, so this is not mutually exclusive. Okay, C. Rolling an even number and rolling a prime number. How many people think it's mutually exclusive? How many people think it's not mutually exclusive? Okay, the answer is no. There is a even number and a prime number at the same time. What number is that? 0. On the dice. 2. 2 is an even number and a prime number. Okay, D. How many people think that rolling an even number and rolling a number less than 2 is mutually exclusive? Not mutually exclusive. Yes. Less than 2 means that number is 1, and 1 is not even, so it's mutually exclusive. Okay, so when you see a probability that's A or B, you have to ask yourself, are these two things mutually exclusive or not? If they are not mutually exclusive, meaning that they can happen at the same time, then A or B happening is probability of A plus probability of B minus probability of A and B. Okay, that formula is a little bit tough. So I'm going to explain why it works. A or B, kind of like our homework problem, yellow or not green, means that either one is okay. So when you see or, you're going to add the probability. Okay, when you see or, you're going to add the probability. Okay, so for example, this one on the homework, yellow or not green. So you're going to add them together. But if there was a block in this jar that is yellow and not green at the same time, then you're double counting. Because you're double counting it, you have to subtract it out. So if there is something that is not mutually exclusive, meaning they can be both at the same time, you have to subtract it out because you're double counting it. Okay.
So you add them together, then you subtract?
I'll show you. So yeah, I'll show you with an example. If they are mutually exclusive, then what you always do is just add them together because it cannot be both at the same time. Yeah, this is much better explained when you actually see a problem. And let's go to the next page. I think it's easier to see the next problem and then come back to this page's problem. All right, so at your high school, a student can take one foreign language each term. About 37% of the students take Spanish, 15% of the students take French, and 9% of the students take Chinese. A, what is the probability that a student chosen at random is taking Spanish or French? So probability of Spanish or French. All right, so I want you to talk to your partner. Is taking Spanish and French mutually exclusive events? Can they happen at the same time or can they not happen at the same time? Okay, talk to your partner. Okay, French or Spanish, are they mutually exclusive? Raise your hand if they are mutually exclusive. Raise your hand if they're not mutually exclusive. Okay, they are mutually exclusive because this says at the front, in the beginning, they can only take one foreign language each term. So you cannot take both at the same time. So they are mutually exclusive. So we are just going to do probability of Spanish plus probability of French, and there is nobody taking French and Spanish at the same time. So what is the probability of taking Spanish? 37%. It is just the percent that they tell you. How many people take that class is the probability. It's the same thing. Okay? So like for example, if I say 50% of this class is girls, the probability is 50%. Because if you pick a person at random, it's 50% chance you're going to pick a girl. Okay, so the percentage is the probability. Okay, and then so French is 15%. So this is going to be 52%. So 52% chance if you pick a student at random, they will take either language. All right, the next one should be pretty easy. Go ahead and read the question and do it. Okay, what is the probability that you choose a student at random and that person is taking Spanish, French, or Chinese? 61%. You just add them together. All right, let me ask you another question. What is the probability that the student is not taking a language? 39.
39.
Okay, 100% minus everybody who is taking a language class. All right. All right, let's look at this. You have this dish, and you have all these colors and shapes mixed together in this dish. So let's look at the first one. What is the probability that you pick something that is round or green? First of all, when you see or, what does it tell you to do? Is it add or multiply? Add. Okay, now also when you see or, it tells you that you need to check if something is mutually exclusive or not. So, can you see something that is round and green at the same time? Yes. So, round and green is not mutually exclusive. It can be both at the same time. Therefore, you need, so when you say probability of round or green, because round and green can be both at the same time, you need to do probability of round plus probability of green minus probability of round and green. Okay, so let's think about this. What is the probability of picking something that is round? 5 out of 9. Okay, there are 5 rounds and there are 9 total. What is the probability that you pick something green? 3 out of 9. Notice you counted these 2 green round ones twice. Do you guys see that? When I was counting the round, I counted 5, including the 2 round greens. When I counted a green, I counted 3, which also included those 2. So basically, I'm double counting them. So therefore, I need to subtract out the ones that are round and green, so then I can, I'm not double counting it. So there are 2 round and greens, so then I have to subtract that out. Does that make sense?
Do we forget about probability because there's no P? On the problem, there's no P in front. Did we just subtract the fractions, or
T?
did we do probability?
Yeah, it is probability. The fraction is probability. Yeah. Okay, so this is going to be 5 plus 3, which is 8, minus 2 is 6. So 6 out of 9, which is 2/3. Good? Okay, so when you see or problems, because you could have things that can happen at the same time, you have to make sure if they are not mutually exclusive, you have to, if they are mutually exclusive, you have to subtract it out. Okay, so let's have you try one. The token is square or red. Square or red. All right, square or red, is that mutually exclusive or not? Is it mutually exclusive? No, they can't happen at the same time. Okay, so the probability of getting a square is 3 out of 9. The probability of getting a red is 3 out of 9 as well, minus the one that is a square and red at the same time, which is 1 out of 9. So that is 5 out of 9. Okay, last one, green or square. Yeah. Oh, sorry. Thank you. What's the probability of getting a green or a square? Can you have green and square at the same time? Yes. So then we need to subtract that out. And what is the final answer? 5 over 9. Are you guys okay so far? Okay, so let's go back to the previous page. We're going to look at a word problem.